this morning, and thank you for joining us. Today we have Lael, the channel manager at MetaGeek, presenting the webinar. If you guys have any questions, feel free to input them in the question box, and Lael will answer them at the conclusion of the webinar. And at this time, I'm going to let Lael take over.
Good morning, everybody. As Krista said, I'm Lael with MetaGeek. I'm the channel manager here, so I oversee our partner relationships. So today we will be talking about a product in the WEIS product line, or a suite rather, WEIS and Channelizer. So it's a hardware-software combo that that delves into spectrum analysis. So the MetaGeek, just to give you an idea of where WEIS and Channelizer is situated within our product lineup, we have three main suites that we manufacture. So we have Insider Office plus WEIS Mini, that's enterprise Wi-Fi scanning. We also have IPA, which is packet analysis software, and then today we'll be talking about WEIS and Channelizer. So it's the spectrum analysis part of our entire product lineup. So Wi-Fi, as we all know at this point, is business critical. Wi-Fi is kind of magical to the outsider and to many of your customers, but even though it's magical and mysterious, it's also expected to work. So things to plan for when you're creating a Wi-Fi deployment, just some things to think about: reputation, how you're perceived, and how your Wi-Fi deployment affects how you're perceived by customers and other businesses. Efficiency, expense, the pay now deployment versus the pay later in troubleshooting and repair costs, customer satisfaction, retention of customers, things like that that you'll want to think about. And MetaGeek is here to help make your wireless deployment successful in a business critical way. So dual band Wi-Fi, that's most of you probably know dual band, 2.4 and 5 gigahertz. Most Wi-Fi deployments nowadays should be in a dual band way. The 2.4 gigahertz range is the accepted industry standard for several years now. 5 gigahertz is becoming more and more accepted. It's still relatively new in some parts of the world. In most first world countries, 5 gigahertz is quite common. 2.4 gigahertz is where you'll see a lot of overlapping traffic and crowded channel space. The channels are crammed together. There's only 3 non-overlapping channels. Channelizer and WEIS help you see how to mitigate interference caused by those overlapping channels and other types of interference as well. So the reason there is so much collision and confusion among the overlapping channels and different types of interference is because Wi-Fi is half duplex. That's just a vocab word we like to use to describe why Wi-Fi is so polite. Half duplex just means that only one device can be transmitting at once. Full duplex would mean that an AP can listen and transmit, or a client can listen and transmit. Half duplex means they have to take turns. So you'll see in the first graphic, it doesn't work if they're both transmitting at once. First, the client needs to talk to the AP, or vice versa, sending data, and then the recipient of the data acknowledges, yes, I have sent that, thank you for sending. So it's a long and slow process, and there's a bunch of different ways that the Wi-Fi standards are set up to deal with this sort of contention in the airspace. Just another visual for explaining half duplex. Since most access points are connected to multiple clients, you'll hardly ever see a one-to-one client-to-AP ratio because that's pretty expensive and could cause even more contention. You'll have several devices connected to one access point. So and the more devices that you get, the more contention there is. So in this example, only one device can talk at a time. While the iPad is talking to the AP, all the other devices and the AP have to wait for their turn to talk, and the more devices you get, the more contention you get. So we'll talk about really briefly types of interference that you're dealing with in Wi-Fi. You'll deal with these 3 types of interference in the 2.4 gigahertz and then 2 types in the 5 gigahertz band. The 5 gigahertz is not as crowded, which is another reason why you should be using 5 gigahertz. We'll come back to this slide in a minute. Maybe I can advance. Okay, 2.4 gigahertz band. You'll see that in this graphic below, there are only 3 non-overlapping channels in the 2.4 gigahertz band. There are several channels, but only 3 non-overlapping channels. And when I delve into the 3 different types of interference, I'll explain why non-overlapping is extremely important. You can't just pick a channel because you'll get adjacent channel interference. So always chant in your head the mantra is 1611, 1611. 2.4 gigahertz. 3 types of interference. This is another way of looking at the slide a couple slides ago. There's co-channel, adjacent channel, and non-Wi-Fi interference. Co-channel interference, it's Wi-Fi, and they're all speaking the same language. So every station, which is another word for device, like a computer or an iPad or an iPhone, every station and access point on the same channel competes for the time to talk. So this is kind of an exhaustingly polite conversation, but it does work. It's slow, but it's all within the protocol. Adjacent channel interference, this would be, for example, if you had an access point on tuned to channel 11 and then another one nearby tuned to channel 10, they'd be overlapping. Because remember, 1, 6, and 11 are the only ones that don't overlap. 10 and 11 overlapping. They compete with each other for the same airspace, and they don't have the same types of polite protocol that would be employed if they're on the same channel. So this is a pretty bad type of interference that occurs in the 2.4 gigahertz band. Non-Wi-Fi interference can occur in 2.4 or 5 gigahertz band, and this is a non-Wi-Fi device that is basically just creating unintelligible noise on the band. So the only way to mitigate this is to move your AP away from the channel where you see the interference. So the tricky thing about this is that you can only see the non-Wi-Fi interference if you use a spectrum analyzer, which WEIS and Channelizer come together to become a spectrum analysis solution. So you can see those non-Wi-Fi devices. It's not something that your computer's built-in Wi-Fi card can see. 5 gigahertz interference. I mentioned earlier that 5 gigahertz, since it's a wider band, it's not as crowded, so you have eliminated adjacent channel interference, which is nice. You'll notice that adjacent channel is missing from this diagram. You still have to deal with co-channel interference. If you're on the same channel, there's still the polite conversation that goes back and forth where each device competes for the same airtime. And you will also have non-Wi-Fi interference from non-Wi-Fi devices. This is another way of looking at the 3 types of interference, but the x-axis in this case would be the frequency. So you'll see channels 1, 2, 6, and 11 in this diagram. 1 and 2, like I mentioned earlier, adjacent channel. This would be in the 2.4 gigahertz band. Really bad setup here. You need to go 1, 6, and 11. So if you have 1 and 2, or if your neighbor or if the business next to you is tuned to channel 2, you're being a good citizen, you're on channel 1. If they're on channel 2, they'll still mess with you because of the adjacent channel interference. Co-channel is the lesser of all the evils. It's the better way because all of the devices are talking according to protocol. It's slower than no interference at all, but it is the best type of interference if you can't avoid any. Of course, open channel would be the best. There's no interference at all. You're out in the country, there's no APs around you. 11 is a completely clear channel, for example. You're golden. So the way to avoid interference, whether that's adjacent channel or non-Wi-Fi interference, is to fire up your spectrum analyzer, see where devices are transmitting in the band, whether that's another AP or a non-Wi-Fi device, and then move away from it. So essentially change channels. Another diagram explaining that. If you fire up your spectrum analyzer, channelizer in this case, you'll see that there is a non-Wi-Fi device with that big red spike transmitting right in the same area where MetaGeek GN, where that AP is located. So in this case, we'd want to change channels to avoid that red spike. Or if you know what the red spike is and you own that device, such as a wireless video camera or something like that, unplug that device. Another visual to explain how interference affects your throughput. On the left is a throughput tester, and you'll see how when the device starts transmitting, it just kills your throughput because the non-Wi-Fi device raises the noise floor and creates a bunch of unnecessary noise that your client has to compete with when it's trying to listen to the access point. So what are some of the causes of Wi-Fi or non-Wi-Fi interference? These are devices that are transmitting in one of your Wi-Fi bands, most commonly the 2.4 gigahertz band. A lot of you may not have landline cordless phones anymore, but those are a usual suspect. Speakers, wireless security cameras, wireless mice, although those are much lower power, so it won't interfere as much, they do transmit on the same band, so they will raise your noise floor. Microwaves are a big culprit. If you find that your Wi-Fi is dropping out right around lunchtime every day, you might want to fire up a channelizer and walk around and see if a Wi-Fi or a microwave is transmitting in your band. It's probably messing with your Wi-Fi. Some unusual suspects that you might not think of, it becoming increasingly common. Home automation, this is the ceiling fan as an example, home automation, Wi-Fi controlled, Wi-Fi enabled projectors, Wi-Fi enabled computers, baby monitors, Wi-Fi enabled cameras that transmit or transfer photos via Wi-Fi, things like that. So we talked about interference and how interference just kills your throughput. So this is where WiSpy and Channelizer come in to the game. WiSpy and Channelizer, WiSpy is the hardware, Channelizer is the software. They go together. One needs the other to operate. They'll help you find and identify RF interference. So this is interference from non-Wi-Fi devices, from co-channel access points, and from adjacent channel access points or other devices. Either the 2.4 gigahertz or 5 gigahertz band, you'll be able to see where essentially the emptiest spot is, and you can identify the best channels for your deployment. Quick overview of the WiSpy hardware product line. We have the WiSpy DBX, which just means dual band. X means external antenna. We have the WiSpy 2.4X, which will scan the 2.4 band. Then we have the WiSpy Mini. That's a tiny form factor WiSpy that feeds 2.4 gigahertz information into Insider Office, which is the more entry-level enterprise Wi-Fi scanning tool. WiSpy DBX is our best seller because it will scan the 2.4 or 5 gigahertz band. Channelizer is the accompanying software with WiSpy, like we've been talking about. It works with all WiSpy models, several different views to look at the same type of information. So it will use data from WiSpy to look at the raw RF transmissions that are coming through from non-Wi-Fi or Wi-Fi devices. It'll also use your computer's network card to see available networks, so that's the specifically Wi-Fi language. And it'll have, there's a feature called network overlay, and then there's a network table. So you can see exactly where the Wi-Fi networks are and how they overlay with the RF signatures that are showing up in the density view. You can record, playback, and save your sessions, kind of like a DVR. Jump around, see if something interesting pops up. You can zoom back into that spot, maybe where someone fired up the microwave. So it is sortable, and you can step through time in that way in your past recording. It's called the waterfall navigation. And then there's just some raw data for those of you who like looking at charts rather than graphs. We have charts and graphs. It'll show you the RSSI of all of the networks in your area. It'll show you the amplitude and dBm of any RF that the WiSpy is picking up. and it'll show you just other stats about the networks that are in your area. The last three bullets I'll talk about: Device Finder, Cisco Clean Air plugin, and report capability in the next few slides. This is the basic. This is the channelizer. Right now we're on version 5. Report Builder accessory is the first accessory I will talk about. This is a really, really handy tool if you are going to a client site or if you just need to document your job for your boss or your client or someone that needs to see proof rather than walk around with you and stare at your computer screen. They need a deliverable. So the Channelizer will have some of these prefab blocks along the right side. You'll see of this screenshot: density view, waterfall view, networks table, channels table. And in the options menu, you can add all the blocks to your report. You can add some of them. You can customize them in language the client understands, like break room or conference room, and put them in order of your survey or in order of the highest importance to the client. You can add your company logo and any other customized text, such as your own suggestions that you created, as well as the prefab suggestions that Channelizer suggests based on the survey. And this is called a software accessory. It's essentially a license key that is a feature unlock of the report building capabilities of Channelizer. Next accessory is the lab accessory. This is if you really want to geek out on your spectrum analysis. It allows custom frequency markers in the waterfall and density view, so you can set customized noise floor and frequency markers to look at different thresholds that you're trying to look for. You can also customize the hardware capabilities like step size, dwell time, resolution, the scanning capabilities essentially of the WEIS hardware. This is another lab accessory, or another software accessory, which is a feature unlock in Channelizer. Last one is this is the last software accessory. This is the Cisco Clean Air accessory. This essentially turns your Cisco Clean Air access point into a fixed Wi-Fi, basically. It's like if you were to plug a Wi-Fi into the AP. You can troubleshoot remotely if your Wi-Fi is in a different country, or if your Cisco Clean Air access point's in a different country and you connect with it over Wi-Fi, you can see exactly what the access point sees and all the spectrum data that it sees, and it'll feed it into Channelizer for you. You can run the same type of analysis that you would run if you were using the Wi-Fi. Device Finder Directional Antenna is the hardware accessory that goes with Wi-Fi. So if you have some troubled devices that you're having a hard time seeing, Device Finder is essentially like radar. It'll allow this to pop up on your screen and see if you're getting closer or if you're getting farther away from the mystery device. It'll lead you right to it so you can get rid of it or unplug it. The way you use it is just the Wi-Fi DBX comes with an omnidirectional antenna. You unscrew the omnidirectional, throw on the Device Finder, and then walk your survey. And then you'll follow this up and down blue jagged line you'll see in the lower right corner. The higher the line goes, the higher the amplitude is of the transmitting mystery device, and then once it goes off the charts, you know you're right next to it. Take a look around and it should be transmitting right near you. So we talked about today types of interference, why that will kill your throughput and be horrible for your network, how Wi-Fi and Channelizer help you locate and mitigate that interference, and the different types of customizations and software and hardware accessories you can build with your Wi-Fi Channelizer toolkit. That's all I had. Are there any questions?
All right. Great job, Royal. Let me check on the questions. Okay. First question, are there any other access points that can be enabled as an analyzer besides Cisco Clean Air? Or is there any that might be in the works down the road?
At this time, MetaGeek is only compatible with the Cisco Clean Air access points, and I'm not aware of any others in the works at this time.
Okay. And next question, how often is your software updated?
Our software is updated, major updates, probably once every year or so, maybe once every 18 months. We do have versions, like the sub-version updates. Right now we're on version 5.2. We probably won't update to version 6 for another year or so, but probably a couple of times a year there's a minor update. And every channelizer software license does include 1 year of the Medicare Assurance Plan, which is just a software maintenance plan that gets you free updates.
All right, perfect. So that wraps up the questions. Thank you, everybody, for attending the webinar. Thank you, Lael, for taking the time out of your day to educate us. If anybody has any additional questions, feel free to contact us here at sales@microcomtech, that's MICROCOMTEC.com. Or if you wish to view any of the products mentioned here today, you can visit us at www.microcom.us. This webinar will also be posted on Microcom Technologies YouTube channel for later review. You can also contact your account managers if you'd like to make any purchases. And you should all have your respective information on them. Anything else, Lael?
I don't think so. I appreciate the opportunity to come in and talk about MetaGeek products today. And yeah, go ahead and contact Microcom if you have any other questions.
Fantastic. All right. I hope everybody has a great day.